So this presentation, this came about through a series of experiences and frustrations with certain aspects of industrial communications. I thought that I was alone in just not being able to get things to always work the first time or properly or fully. So I did a little bit of, I'll say, research. I interviewed a whole bunch of people. Thank you to everyone who was willing to spend a bit of time talking to me. Turns out I wasn't alone. There are, well, we'll see from the presentation, but there are aspects of trying to integrate NI hardware with industrial communications that cause frustration. I'm surprised that I've got any hair left, I have to be honest. So thank you to everyone who donated their time. I did say to everyone that it would be an anonymous gathering of information, so they didn't have to worry about any of these facts. And it was surprising how many people actually said, no, it's fine, you can tell everybody I've said this, I don't mind. Still, it's anonymized. I've not included everything. So some of this is my opinion and experience, a lot of it is other people's experiences. So it's a crowdsourced presentation. And again, we've got AI-generated backdrops, so they look a bit squiggly. So I'm talking about industrial comms, not uncommon. I work in an environment where I take LabVIEW and NI's hardware and I try to put it into equipment. I try to integrate it, so it needs to talk to other stuff. It needs to talk to motors, it needs to talk to sensors, measurement equipment. And you can't do it all through the modules that you would get in a chassis, so sometimes you need to talk to third-party equipment. And that interface, hopefully you've got a good standard there that you can lean on and you know it'll be reliable. So there are a few examples there I've thrown on the screen in case you're not familiar. If you've got a facility with production flow lines, you might have individuals, operators working there. They might have screens in front of them. Those screens need to relay information about what they're doing in front of them. You've got automated test benches, of course. Those can be quite complicated. They might have lots of motion, lots of control, lots of measurement, cameras, that kind of thing. You've got your site overview display. So you're talking here about gathering information from all over your plant, bringing it together, probably to some kind of server backend. Again, that could be a LabVIEW facility or it could be something else. And then wireless sensors, of course, if you've got condition monitoring or just environmental safety. Lots of different possibilities, and all of them need to talk in a reliable way. You don't want everybody from each manufacturer producing their own protocol on how to interface with these things. So it's not uncommon to have a handful of different industrial comms, and we need to be able to lean on all of those. So I've worked with some different equipment, and I'm going to use this piece of equipment as a backstory to the presentation. This is from a company, it's Belden, Lumberg Automation. It's an IO-Link hub. Now, if you haven't worked with IO-Link before, you're not the only person. It was new to me. But IO-Link is a technology that allows you to take sensors, make them slightly smarter, and connect them to your enterprise. And you might have lots of these, and if you don't have an IO-Link interface, you need something like this. So this has got 4 IO-Link ports on it, so it acts as a hub. So it'll bring in and allow you to connect to up to 8, sorry, did I say 4? I've got 8. It's got up to 8 IO-Link ports on there. And for it to be versatile, it needs to work with a variety of different industrial comms. So it does the translation for you. It allows you to talk to it. Just by turning that first little pot there, you can either use Ethernet, IP, Profinet, EtherCAT, Modbus, CC-Link. That's good. So that means that someone out there with an existing setup would probably be able to pick this off the shelf and use it immediately, switch it to whatever mode they want to use. So I had the actual requirement to interface this to a compact Rio. So lots of options there. Surely one of them is going to work. Fantastic. I hear some laughter, so I know some people know where this is going. It also supports Industrial Internet of Things, IIoT. So we've got a few other protocols on there, not designed for the real-time data acquisition side, but more designed for interfacing with it for maintenance and configuration. So it's quite a clever little device, little web service on it, so you can even log into it with the IP address. You'll recognize some of those names down the right-hand side. Now, I know this presentation is actually quite long, so if I start yabbering, I'm going to try and move on quickly. So first of all, most of you have probably come across non-standardized interfaces. You've probably bought a piece of equipment and you've thought, I need to use that. How do I connect that up? Oh, it comes with a serial port. All right, what's the protocol? And you get the manual. And I think we already had a slide before. You get the manual, and then some interns developed some ASCII-based interface, and it's very poor. And I have had no end of instances of equipment like that. Terribly integrated temperature controllers, handheld sound meters that are as an individual device, it's actually really clever. But as soon as you plug in that RS-232 interface, you're in for a world of hurt. And that product there, exceptionally good leak tester device, standalone, benchtop, programmable. And again, it has a serial interface, and you'll be up late trying to get that to work reliably. So you don't want RS-232 with a non-standard protocol if you can help it. It'd be much better if the manufacturers actually adopted one of the more standardized industrial comms. Now, a friend of mine, James, I think it was, shared an article with me, and it was this. It was a research paper which shows the rough market share of different industrial comms out there in establishments. So I thought it was quite interesting to see what the predominant industrial comms are. And you can quite easily see from that pie chart that industrial Ethernet types are the majority. The older field bus types are dying and fading, and you can see we've got growth on the industrial Ethernet side. And obviously we've got, that doesn't work, does it? So we've got Profinet and Ethernet IP, two of the biggest ones, and they still got the largest slices of the pie. And then we've got EtherCAT, which is coming up fast, which, you know, EtherCAT's the new kid on the block, really, and that's in third place. Now, all of the ones on the right-hand side are all considered time critical. You can use them for your real-time interface to a distributed system. So any of these would be fine for me. I'm quite happy to adopt any of them in my system. So let's start with the first one. Profibus. Now I've got some notes on here because obviously some old history stuff and it's quite relevant. So Profibus is the oldest of all of the ones on that list. It's been around since like '89. And it's field bus communication for automated technology. Siemens were the early adopters, and they're obviously big players in industrial automation and PLC. There are over 80 million nodes worldwide for Profibus. And it's an openly published standard, so you can go and get that standard and you can integrate to it if you need to do it as a custom. So Profibus, originally is quite old. You know, we were getting something like 31 kilobits a second through a two-twisted pair interface. And then they developed DP, which is up to 12 megabits a second. That also uses shielded twisted pair cabling. And that's on the Profibus side. I think I'm not keeping up with my slides. And then Profinet is based on Ethernet. So that uses standard network cables. And that's the more modern, more advanced version of that. And obviously with the Profibus side, you tend to have a daisy chain of devices, and I think with Profinet, you get a star topology if you want. It can be more complicated. Now, I profess I'm not an expert on stuff here. Half of this is from the organization's websites, so it should be correct. But if anyone out there knows, and they're like, no, you've got that wrong, it's quite possible. But I've tried to make it accurate as I can. And obviously, in these industrial environments, they tend to expand. So there's also ProfiSafe for safety-critical applications, ProfiDrive if you're driving motors and things like that. And there's a lot of material out there. So what are my options if I want to incorporate Profibus? Well, NI originally partnered with Comsoft to provide Profinet and Profibus hardware and driver features. Then that IP was bought by Conbus. So Conbus bought Comsoft's IP in about 2017. And now NI and Conbus don't really talk to each other. It's not a great position. It means that if you want to adopt this stuff, you're not using supported technology if you want to start with an NI platform. So, for example, if you want to go and buy some Profibus hardware, you can go to the NI website, you can do a search. Yep, there it is. Profinet is in the text, Profibus is in the filter list. There's one device, okay? At PXI Profibus, which happens to still have the Comsoft logo on the website, but that's a small detail. And it's not available anymore. 2021, so you can't do that. Well, what about the compact rail? Similarly, there's a Profibus module for the compact rail that also isn't available anymore. So you can't get the hardware. So even if you wanted to try this, you're looking on the second-hand market. Well, what about Profinet? That sounds a bit easier. Surely all you need for that is an Ethernet cable and the right drivers. We all have Ethernet ports, so that should be simpler. I'm not sure how simple it is, but it's certainly possible. You can turn your Windows laptop and turn it into a controller for a Profinet network. So that should work. Still, though, if you want to do it in LabVIEW, you still have to use those CUN bus drivers. And you can get those. You can go to VI Package Manager, and you can find those Profinet drivers, and you can download them. But it is not, they have not been updated in a while. I did install those, which is how I got those screenshots, and it slammed a load of 2014 stuff on my laptop, which might explain the trouble I had last night. I don't know for sure. It might not be related. So I did contact NI. I wanted to find out a little bit more, and yeah, this is their statement. NI's relationship with CUN bus has ended and support for Profinet is limited. I would not recommend this approach. So that threw that one out. The most popular industrial communications protocol is not an option. So then Ethernet IP, equally popular really by market share. Ethernet IP. So I had a look at Ethernet IP. This is also a factory and process industrial protocol. It's established a bit later, 95, and they use standard Ethernet network transport layer. It adopts something called the Common Industrial Protocol, CIP. And that's all managed by the ODVA. Quite a lot of these protocols get handed off into some independent organization to help adoption. You know, it increases the chances of people using it if it's not maintained by one particular company. So that's quite a common story. Now, because it sits on the network level, if you're familiar with the OSI model, and I'm not very familiar with it, but some people are, the lower down that layer you sit, typically it means that you're able to get I think it's the fastest behavior, the lowest lag, and that kind of thing. So it's probably a good thing that the Ethernet IP drivers sit at the session level 5, which is the session level, not right at the top. Someone else might be able to fill us in on a bit more detail on that. And again, like with the Profi one, there are other devices. There are others built on this as DeviceNet, CompoNet, ControlNet. And this was all developed originally by Rockwell, again, another PLC manufacturer. And this bit was interesting to me. It adopts a very strict object-oriented design. Now, if you're not into classes, then you might think, oh, but it's not about classes. Although it is in a way. You don't have to worry about like inheritance and weird stuff like that. So let's have a quick look at a typical Ethernet network. The credit is given in all cases. This is taken from an online blog. So there's an example of a controller with multiple nodes. Each node and the controller all have an IP address. It's an Ethernet network. So you can identify them in order to be able to talk to them. So we have an IP address. That's a good start. And the nature of the device is that it's recognizable by the object ID that it reports. And these are defined, and there are loads of them in the documentation, so different devices conform to different categories within the object ID range. So you get things like DC drives, analog input points, presence sensors, position controllers, that kind of thing. Now, there are a bunch of classes. So, for example, a really important class is the identity object. If you want to know more about that device, what's your vendor, what's your part number, what's your serial number, it has to report that back, and that's the identity object, which is class 1. So if you want to go and find out what's out there, you just need to talk to it via its IP and ask for all the information under class 1. So we'll have a quick look at that. There are mandatory attributes associated with the ID. So if you want to produce a product that's compatible with Ethernet, it needs to at least respond to this class request. So it's got the vendor ID, the device type, product node code, etc. And then there are further ones, optional ones. You do or don't have to include those. The list is almost endless. And it's quite a simple method. You would call an attribute. You can get the whole class, or you can get one attribute from that class. So in this instance, if we wanted to get the product code, we would use that IP address, class 1, instance 1, attribute 3. I didn't talk about instance, but some classes exist in multiple copies on a device. On my I/O link device with 8 I/O link sensors, there are going to be 8 versions of one of the classes that represent what's on each of those ports. So what have we got from NI? We've got a toolkit. It's a good start. So we can download and install the NI Communications for Ethernet toolkit. Appreciate that. And it gives you a handful of VIs on a palette, which is good. Mainly, though, you'll be in the messaging palette. The messaging palette is how we communicate with these devices. Some of them are specific to like Rockwell PLCs, so AC SLC 500, unrelated. That one, I was just saying we might want to get an attribute from the device. We might want to get its product code. So that's the VI we want to call. So this is how we would call it. Get the attribute, you put the IP address in. Clearly the snapshot is real and the text is different, so apologies for the discrepancy between what's on the snapshot there. But it does work. You can call that and you'll get a response from the device, and it comes back with type 12, which is communications adapter. Makes sense. So just to wind back a little bit, when we're talking to one of these Ethernet devices, we need to know its IP address, the class we're interested in, if there are multiple instances, which instance, and then the attribute ID. But then also there's a service code. When we're talking to this device, we might not want to get an attribute. We might be telling it to reset itself, or we might be setting a variable. So each of those different methods are service codes. So there's a wide variety of service codes on the Ethernet standard. So that's really important. So there's an example, get single attribute. We've covered that one. That's actually service code E. Get all attributes, probably use that one more often. That's code 1. Reset, 5. This one, get ISDU data. That was really important to me on this device because that tells me what's connected to the I/O link port. So that's service code 4B. I need that one. Where is it? It's not there. You can't change the service code in the toolkit. The toolkit is protected and locked, so I can't even augment it. So I spoke to NI. And eventually, after a lot of checking, they came back and said, I've checked with R&D, and unfortunately, there's no way for us to be able to implement the ISDU communication using our Ethernet IP drivers. Does anyone recognize him? That's Compo. CompoNet was one of the standards in there. Right, so that killed Ethernet. I can't use that either. Not good. So then the third one, EtherCAT. EtherCAT is a relatively new standard. Let's have a quick talk about that one. It's a new kid on the block, developed originally by Beckhoff. Now, again, that's been moved off to an independent organization, the ETG, around 2003, it says here. Again, it's based on Ethernet networks. It's very simple to implement. It also has automated network device identification. In my opinion, it is the better of the three, and I think it'll actually overtake the first two. So if I was to pick one, it would probably be EtherCAT anyway. It's real time, you've got kilohertz cycling. When it talks to devices, it actually does them all in one hit. So if you've got a network of EtherCAT slaves, we don't talk to them one at a time. A message payload goes around the whole ring, and it talks to them all effectively at once. So it's actually quite powerful. The theory is you can have up to 65,000 EtherCAT slaves on one link, which is phenomenal, really. I've just realized I'm not advancing the slides, so I'm just going to do this. Again, all this information is just from their sites. Now, I've worked with EtherCAT before, so I knew it ought to work on my compact reel. So I wanted to give it a good shot. So I was quite excited to try it, to be honest. And just quickly, that's a photograph that you'll find online, and that is 10,050-something slaves, EtherCAT slaves, all on one device, fully working, one controller, connecting. They were just kind of proving a point when they did that. They brought production to a halt for a few days, but... So here's an example of an EtherCAT setup. Again, this is stolen from credits there on the screen. It's their actual website. So you've got a master, and you've got your network running from left to right there, and you've got multiple devices. And across the bottom is an example of the datagram. It's not called a datagram. Let's call it a frame or a message. And that's what's pushed out by the master. So it goes through each device one at a time, and each one of them processes the bit that it's responsible for dealing with. And when it gets to the end, it comes back. Sometimes it's a ring, so actually what goes out of the last one goes directly back into the master. And it makes it very efficient, very fast. So my example, I've got a compact Rio, and I've got my I/O link hub. Let's just get rid of everything else. Now, a few things that are worth explaining here. The messages are sent on a clock, and the messages are sent cyclically, and they're continuous. And what NI have done is they've matched that with a scan engine on a real-time device. That's really cool, because that means that if I fire up the scan engine, my EtherCAT system is live. So that's really easy to set up. Also, EtherCAT slaves, in order to know what it is, you need a definition for it. So every EtherCAT slave has something called an ESI file, a slave implementation file. And it's basically an XML file with lots of information in it. And you can load that into your LabVIEW environment or TwinCAT environment or whatever environment you're in. And it basically tells your project what's on the network. So you can just go and download all these ESI files and have them ready on your machine so that when we first connect to an EtherCAT setup, you already know what the devices need in order to operate. There's a handful that come as standard with your EtherCAT toolkit when you install it from NI. But generally, you probably want to go online and get the latest ones. And what happens is, if you've never used this before, it's quite cool. As soon as you connect to your real-time device, the EtherCAT side will go off and discover what's connected to your machine. So this is the result. It goes off and it discovers I've got an I/O link hub, and it knows what it is, and it knows what the I/O are, and it will put them all as variables into your project. Now, those variables, you just drag and drop into your block diagram, and then you've got your I/O, in theory. You can also network publish these, so if this is a remote system, you can actually have them hosted, and then you can connect and use this distributed system manager to actually log in and have a look. It's very powerful. I really like the way that it's neatly integrated into the project environment. So there's an example. You can just drop a couple of these bytes down. So in this example here, the first I/O link port is configured as a 2 bytes in, 2 bytes out device. So basically, it will tell me what's going on in 2 bytes, and I can configure it with 2 bytes. It doesn't get any more detailed than that, so you have to do your own interpretation of those bytes. So if it's a bit pack, and it contains things like on and off and drive and not drive and stuff, you just have to do a little bit of code for that. But that's not too bad, and it's no different than you'd have to do for any other kind of driver anyway. And of course, it's linked to the scan engine, so you probably want to put it in some kind of timing. So you're not just polling them as fast as you can, you're actually polling them synchronized with the scan engine. Did it work? No, not really. Yeah, sadly there was a problem. If you see this, you can start crying straight away. Because it doesn't really help, it just tells you something went wrong, you've probably not configured it right, go work it out. And there are no debugging options, there's no way to really get any more information about it. It's nice when it works straight away, and I've got a demo which I'm hoping will work straight away, because it is really cool when it works. But if it doesn't work, you're in trouble. And you are going to be installing Wireshark, you are going to be sniffing the packets, you're going to be looking to see what's being sent that shouldn't be, or what's missing. You're going to be talking to NI, you might be talking to the vendor. I talk to NI, and the problem here with this particular Belden I/O link master is that being a hub that talks to 8 other devices, it's called modular. So when communicating to an EtherCAT slave that has a modules section defined in the ESI file, the NI EtherCAT master will poll object F050 automatically. The latest EtherCAT specification updates this object to be optional. The NI drivers expect it. If it doesn't exist, it's not going to work. You can't make the device create that object. That is a problem, and it cannot be worked around. The device just isn't going to work. This is because NI's EtherCAT drivers are old. They haven't been updated in years. Now, these are NI's words, by the way. Certainly not since 2017, possibly older, Dynamic memory allocation is not supported, so interfacing with the latest range of products requires advanced modification of the XML profiles, those ESI files, to add elements required to ensure working communication. There are no plans to add full modular device profile support to our driver. A full redesign would be needed, and there are no workarounds. At this time, we are not prioritizing further investment. It's sad because it's brilliant. It's just out of date. And I don't think it would really take them that much. I know it says a full redesign would be needed, but my understanding was NXG was a rebuild of a lot of stacks, and some investment went into the EtherCAT stack. So some work was done, but I guess porting it over to this isn't as simple as it might sound. That last one, by the way, wasn't tech support. That was someone much higher up. Again, anonymized. So I couldn't use that device. So as it turned out, there is another manufacturer who makes something very similar. This is IFM. It functions in the same way, but in the documentation, class F050 exists. Ooh. Okay, we'll give that one a go. So we take that device, heavy modification of the ESI file. I cannot understate this. You need to become an EtherCAT expert. You need to totally understand the XML definitions, the object definitions. You need to read in detail the EtherCAT specification. Now, a lot of that is available from their website, or even Beckhoff's website's really good, and you can eventually get it to work. I got this one to work, and that was such a relief. So what I've done there is I've connected a little linear drive. That's a motor, stepper motor. It's an I/O link interface to that IFM, and I am able to control it, and I am able to read its position back. So that was a huge relief. Managed to get it to work, but I cannot understate how hard that was. It really shouldn't have to be that difficult. And there are extra features which I haven't gone into. There are methods so that you can write SDOs, service data objects. I guess it's worth going quickly into the variables you get for the PD, or the process data, which is the stuff that you want to get quickly all the time, so that your system's up to date. Service data objects, you only want to send those when you want to make a change, you want to reconfigure it, or you want to just occasional communication. That's fully supported as well, which is good. File over EtherCAT is also supported, so you can actually update the firmware on the thing if you wanted to, although I wouldn't recommend trying to do it through your LabVIEW code. Right, what's next? I don't want to be surprised by the next line. Okay, so I did eventually get that to work, but it wasn't a lot of fun. I had another EtherCAT device, and now it's actually not me that's working with this, it's a colleague who's in the room. And that didn't work. We couldn't connect to that one either. Now that is a relatively simple device with a relatively basic EtherCAT interface, yet it didn't work. And again, NI tech support was needed. We worked with the supplier, kinda. We worked with NI, and after lots of Wireshark logging, we found out that there was, in this particular instance, the NI drivers were setting a variable needlessly on the device, and it was causing it to flake out. Now, if you've used TwinCAT before from Beckhoff, that's, they created EtherCAT, so you'd expect it to correct, as it were. You can do a similar thing. You can connect it up. It'll discover the devices. It'll turn them into operational mode, and you can interface with them. It's just a way of testing that the product isn't bad, and you haven't got a duff unit. But also, you can Wireshark sniff the communications. What did TwinCAT do differently to the NI drivers? And that's where you find just one class is written by the NI master drivers that the TwinCAT drivers don't set. Who knows why? Nobody does, apparently. There isn't anyone at NI anymore who knows anything about EtherCAT. Also, if you ever see this error, there is no workaround. You have to uninstall EtherCAT from your target, reboot it, and reinstall EtherCAT. Somehow it can get itself in and twist and corrupt its own files. It doesn't happen often, but if it does, don't waste your time trying to fix it. You just literally have to go into Max, remove the software, and then put it back on again. Tip, if you've got multiple devices, now if you put 3 of those Beldens on, or the IFMs, they're not going to be connected to the same I/O link sensors. They're going to be different. So they need a different configuration. If you've modified the ESI file to specifically say, I've got these devices on these 8 ports, you need a different ESI file for the next one, and a different ESI file for the third one. So you can create these ESI files and you can put them into LabVIEW, and then when it goes out and discovers the devices on the network, it gives them all ESI1, because they're all the same product. So if you want to put multiple slaves on, it's just a tip. If you want to put multiple slaves on, don't use auto discovery, because LabVIEW will just assume they're all the same. It doesn't give you the option of picking which ESI file you want to apply. So that you can work around that one. Oh God, it's time. Okay. So I wanted to show you, because I really like the way EtherCAT is implemented, I wanted to quickly show you this. So what I've got here is a compact Rio, no hardware in it, there are no modules, and this is a borrowed EtherCAT slave from our back-off sponsors upstairs. So they very kindly loaned this to me. I've got an EtherCAT cable, which is a network cable, connected to the EtherCAT port on this compact Rio. If you're not familiar, most compact Rios, you're allowed to turn the second network port into an EtherCAT port. Yeah, most people have probably done that. Right, and the AV guys upstairs have been very clever, and they've split the screen. Would you mind actually putting it back until I write the code, please? And then we'll switch to that mode and allow everyone to say thank you very much. So what I want to do, duplicate so that I can see on my own screen. So, right, this is all connected. Just want to check everything and it's switched on. Yeah. So I've got LabVIEW. I have my compact Rio. You can see this, right? Yeah. So I have my compact Rio. I'm going to connect to it. This bit's not special. Let's just hope that works as normal. If I can't see it, I'll give up. Right, okay, found it. So I haven't got any EtherCAT in that project yet, okay? I saw a small cheer there when I connected to the compact Rio. First marvel. Right, so if we want to use EtherCAT on here, first thing we do is we go to our we go to our compact Rio, we say new target, and I'm doing this because most people have probably never seen this. And we can say, right, I've got an EtherCAT master on my compact Rio. It is that port, right? Great, okay. Discovery. Boom. Variables. So it's gone out, it's found the slave, it knows what it is, it's used the ESI file to determine all the different I/O, and it's put them into the project. So now I can quickly create a VI. Let's take one of the digital inputs. Let's take one of the digital outputs. So digital input, there are actually some little switches on the front, so I'll just create an indicator for that. And then there are some LEDs on the front, so I'll create a control for that. What I'm going to do is make these a bit bigger. Best front panel ever. Right, so normally you would wrap that in a while loop, blah, blah, blah. I'm going to do the sinful thing of run continuously. Just need to give it a name. Right, now I mentioned that the scan engine needs to be running. It is active, scan engine is active, so if Ivy would very much like to switch that mode for me and we can see the front of the unit, I'm going to go around here, and this switch, hopefully, hey, and with a bit of luck, we should be able to see that LED as well. Okay, bit of fun, but similarly, it's how easy was that? You can't deny, if you wanted to use an EtherCAT system and you can get it to work, it's so powerful. Right. Is that right? Excellent. So, ooh, got a tick. I've edged a bit, but I got there. So, EtherCAT was a way forward. Would I recommend it? I would recommend if you want to use it, you get the hardware first, you try it. And I know that's not always possible. Not every vendor wants to loan you one of their pieces of equipment. But there's a chance it's not going to work. Right, moving on, what else have we got? I'd like to cover as many of them as possible, but I appreciate I'm limited on time, so I might skip through some of these. Originally on that Belden device, we've got Modbus TCP. Again, this is dated. It was invented by Schneider Electric for PLCs. It goes back to '79. It works on the idea of coils and registers, and you can read and write these. There are loads of Modbus libraries. It's an open standard. NI have their own Modbus library. I haven't used Modbus very much, so I depended entirely on everyone that I was talking to in the community about their experience. So most of this feedback is actually from them. Excuse me. Right. Yeah, last point. Modbus for me was not an option because it turned out that the device doesn't expose any of the I/O link connectors through the Modbus interface. It was technologically not possible. Modbus doesn't support that. It's not advanced enough. So unfortunately, I was very quickly able to rule out Modbus. But generally, as an interface, people are using it. And generally, people are quite positive. But you do, in these interviews, people love to tell you what went wrong. Intermittent bug with the Modbus mutexing. NI's drivers are locked. So fixing meant unofficial unlocking and pleading with NI. You could actually see different implementations from NI R&D for Modbus, indicative of each suffering the same issue. But no public fix was ever released. Now, I can't say whether that's correct or not, but this is what this guy told me. So that suggests that the standard NI Modbus drivers might have a problem, so you might be better off looking for a different one. Someone else, there are a couple of bugbears with the NI Modbus toolkit, but it's simple enough and works well enough. With the decline in NI hardware, often I'm looking for ways to convert a device to Modbus. So that's a good idea. If you've got a Profibus slave, switch it to a Modbus device, and then there's a really good chance you'll be able to talk to it much more successfully. NI support for Modbus is still good. Excellent. And that is a link to NI's open source Modbus implementation, which is, I don't think, the same as the one that's on the tools network, which is a locked one. Right, we had a few agreements. CAN. Now, I haven't worked with CAN. CAN is automotive. This was invented in the 80s, implemented in the 90s by the auto industry. It's a controller area network. It doesn't require a master or a controller. My understanding is you just take a whole bunch of devices and link them up, and they will just start chattering. It's really simple and cheap. It's what the automotive industry want. They don't want network cables running around their cars. They just want a couple of wires if they can manage that. The way that communications work, given you don't have a master, is everything talks whenever it wants to. But anything with a higher priority than something else gets to tell it to shut up. So two devices talk together, the priority one wins, and the other one waits a bit and then has another go. That obviously works. And like with most standards, it starts off with a particular structure, and then they have to extend it. So you've got the standard format, you've got extended format. There'll be some people in this room who are expert at CAN and probably grinding their teeth at what I'm saying, because I'm probably not getting all the details exactly right. But again, I've got no experience, but I was trying to cover everybody's grief. So NI do offer PXI, USB, and C-Series CAN interface cards, which is good. And they released a software suite called XNet. It's a well-developed suite of software, good. It supports CAN, but also others like LIN, or LIN maybe, and FlexRay, and automotive Ethernet, which is all good stuff. And the way that frames work on CAN is they're all predefined. So you need to have some definition of all of these, and my understanding is that's a database, a special type of database for CAN. So you need an editor, so one's built into XNet, all very good. But I've heard that now NI are offering something else. NI are now offering something called VCOM, Vehicle Communications. It's powered by someone else, Acodis maybe. And people are telling me that it works on the existing NI net hardware, which is good. It offers additional features, which is good, but it's also much more expensive. So again, the comments that I got back from people, everyone who's used the CAN hardware from NI got what they needed to get done. It worked. So it's a thumbs up for CAN. If you want to use CAN, just beware of some of these comments maybe. IPv6 apparently is a problem. XNet supports it, but the automotive toolkit does not. NI have promised, and NI have not promised a v6 compatible release. However, our customer is already using it, and they're doing it with different hardware. Now, Vector is another manufacturer of CAN interface equipment. So that's a competitor. So we need to keep up with that. Someone else said VCOM will replace XNet, which is far more feature-rich, but it's also much more expensive. Now, at the minute, I believe NI's hardware per channel is cheaper than Vector's. I think that flips over when you switch to the cost of VCOM. So that makes it not cost competitive. Someone else said XNet supports database importing, but the automotive toolkit does not, and VCOM also does not, which surprises me. Again, I can't validate that. And NI doesn't even understand their own hardware. They often spec the 8623 when actually you're needing 8523 for more automotive Ethernet. I think the lesson there is not everyone in sales totally appreciates the difference between all the cards. So if you rely on them to tell you what you need, I'd double check just to be sure. Support for XNet is poor. They don't understand their own error codes. There's one in particular that says contact NI, but NI themselves have no idea how this error occurs. They just don't know. Solution is to reboot the computer. And that fixes it for a while. I haven't used NI support for 2 or 3 years. It is slow. This is, again, a CAN-related complaint. I've never gotten a successful response from NI support. I've always figured out stuff on my own. I think most of us would probably say that, sometimes we don't bother NI support if we think we can figure it out, because it can take 5 working days before you get to a response, and you could probably work it out in a couple of days yourself. With the troubles I was having with Profinet and Ethernet and EtherCAT, I had no choice but to contact NI, because these things were deep issues. Okay. If you get into CAN, there is something you must definitely look at, and that's Brian Hoover's blog. Brian Hoover has worked extensively with CAN in NI's hardware field and software field, as well as some of the other manufacturers as well. His blog post is really informative. I read it to just get clued up on CAN before this presentation. He's reworked a whole bunch of drivers. Vector produced drivers that were basically wrappers for their DLL, and they didn't do a great job, so he decided to rewrite them. And same again for Quasar and Intrepid. So he's released these on his blog. A whole bunch of CAN tools that are all compatible with XNet. So you can actually interface and swap in and out of them. They've got a similar API. Really good job, totally free. Just go ahead and download those. I don't think there's any question. So CAN, pretty good. OPC UA. This is the unified architecture for OPC. I have used this one as a client, or rather, a colleague of mine who's probably in this room right now did most of the work. So OPC UA is a standard for data sharing within industrial settings using cloud-based technologies. Again, this is from their site. So TCP/IP, WebSockets, MQTT. And it adopts an element of security as well, security measures, so you can put user accounts and passwords into the interfaces. And it works on a client-server publish-subscribe pattern. So you can register for information from a service, and instead of it just telling you it every time, you just hear the change. So that's quite efficient. It's open source, so you can go ahead and read the standards. And I have a toolkit for this, and I've used it. In LabVIEW 2017, I think it was, we used the OPC UA toolkit and created a very good client solution to talk to a PLC, which was running the service, OPC UA. Now, I wanted to put more stuff on this slide, but installing that toolkit killed my NI LabVIEW installation on my laptop. So I don't have any examples, I don't have any block diagram elements. Uninstalling it did not fix it. I no longer have LabVIEW on this machine. Hence, you saw my demo from within a virtual environment. I like OPC. Whoops, I like OPC UA. I've used it. It's good. Comments from people. Good experience with OPC. When trying to abstract, I tend to go that route. Gives me a good feeling. Oh, that was the only comment. So, but a few other people did mention it, but they didn't have a worthwhile statement to write. But most people have had good experience with that. Very quickly, this isn't really a protocol. It's kind of well, it is a protocol, but time synchronization. This should be like really close to NI's heart, right? Because when they're selling their equipment with synchronized clocks across all their devices, it's a concept designed for distributed system clock synchronization. EtherCAT has TSN. NI adopted TSN on their hardware. OPC UA is adopting TSN. And you can get switches with TSN-enabled features in them, so you can share this like clock information across networks for synchronizing them. And you can get better than 1 microsecond of synchronization between 2 devices, excuse me, anywhere on the planet via a GPS. Use GPS as your master clock. Very clever stuff. I spoke to someone who found out that NI divested from TSN support 2 years ago. Future controllers won't be prepared to support it. NI don't see it as important. That surprises me. I don't understand that decision at all. This particular person had just done a massive solution using TSN for time synchronization, and they wanted to upgrade some kit. And NI didn't know which kit supported TSN anymore. It took them a lot of figuring it out, going back to like drawings and things to work out what did. And knowing that they can't upgrade it in the future and create new systems means that I'm going to have to go find another hardware vendor. So I appreciate I'm out of time. I've got 3 slides left. This is my summary of each of these protocols. That sucks. That didn't go too well for me, but it should work for people who don't need to do specifically what I did. But it's a lockdown tool set, so you can't augment it. So if it doesn't quite work for you, you can't use it. EtherCAT, I love it. I love the way that it works. You saw in the demo how quick it was to set up, but it's out of date. It's unlikely to work with a modern EtherCAT slave. It is so difficult. The Belden didn't work. The IFM, I had to massively modify the XML files. That leak tester, and I were setting some variable they shouldn't have set. None of these things worked out the box, and they should. You should just be able to plug it in and turn it on, and it'll discover these things. So I'm disappointed. But if you can get it to work, it'll be a green dot because it will make your life so much easier. Modbus TCP, pretty good. Everyone had a good opinion of that. CAN bus, most people got what they needed to get working with CAN, but they said support was poor. It doesn't look like this VPN thing going forward. Not VPN, VCOM. I don't think anybody's happy about that, but I guess time will tell. OPC UA, let's hear it. Nobody's any problem with that. That's good. And time synchronized networks. That's disappearing. So that's not good news either if you want to use that. One of my interviewees was someone at NI, as you saw, because it was somebody high up and important at NI. And I had a really good conversation with them. They were very good at telling me the current situation. A lot of it was kind of in confidence, so I'm not able to really state anything, but we kind of agreed on this. NI continues to provide support across the board on these protocols with investments that align to our business unit priorities. Okay? Future. Unless you've been living under a rock, you'll be aware of the Emerson takeover, buyout, acquisition, whatever the right word is. I'm not in that field. And I clearly can't talk about this. This is very high level, very corporate, and very secret. It leaves a lot of us wondering what's going to happen. Emerson must clearly value what NI are doing. And a big part of that is LabVIEW, and a big part of it is their hardware. So we've got high hopes for what's coming next year, but at this point, obviously, it's all up in the air. I did a quick search for information on it and very quickly found this quote from the president of Emerson. We are pleased to reach an agreement with NI, whose best-in-class test and measurement product and software offerings accelerate Emerson's progress towards a cohesive, higher growth and higher margin automation portfolio. I don't know how clued up they are on the capabilities of all of these industrial comms drivers and solutions from NI. If I was at Emerson, I'd be worried. So I just want to again thank everyone who let me interview them. This is a happy place, so let's all go and have a beer. We've run out of time for questions, I believe, so I'm just going to walk off the stage. Discord group, if you have any questions, please. Thank you.
Yeah, if there's one or two, let's do one or two.
Where's the first?
Rich, up here.
Hello.
Did you not investigate Milcan as well? Did you investigate Milcan?
Nope.
Good answer. Right, let's go for a beer.
Honestly, I've not heard of that one. Is it prevalent?
It's, Sorry, I'll stop shouting. It's an avionics platform based, or actually, sorry, it's a military-based platform which uses a time synchronization pulse on a CAN network.
I would suspect NI are aware and
didn't do anything about it. Yes.
No, I was going to say the other actually, because I think that's one of their BU interests.
Really?
Yeah.
Oh, that's good. They're getting rid of it in about 3 years.
But I would suspect that and gRPC tend to be where their interests lie at the minute.
Yeah. Yeah. Cool.
Something called DDS. Does that ring a bell? I think that one also. Stop laughing. That's not fair.
Dude, I was using that 30 years ago.
Okay, I see hands, but I've got people waiting to take the stage from me. I'm going to get carried off in a minute.
We'll do one more. Last question.
I just think that was excellent to see. I think after 25 years, many people putting the whole company behind NI, the last 5 years have been absolutely abysmal, and I can't believe how bad they've been, especially on not educating people as well. I guess, is there something we can do as a body, as GDevCon, to really push this back to Emerson, to look, there's a body of people dying here. And this has got to get better, because of that, to not support Profinet, I've been through all of those, and to not support Profinet is just a joke, and it's just got ridiculous. So hopefully as a body we can do something about that and help it move forward.
Yeah, at GDevCon we are aware, and we do want to promote and help and support, and it has come up in conversation what we can do. I guess use the feedback section of the Discord and put these ideas forward to remind us that we should pursue them harder. Thank you. Right, shall I stop? Thank you.